In this video, we're going to set up Neovim to be the almost perfect editor for working with Node.js. By the end of this guide, you'll have code completion and auto-suggestions, linting with static analysis, auto-formatting on save, and powerful debugging capabilities. I've also added in a custom LSP function at the end. We'll be supporting both JavaScript and TypeScript with this configuration, so you can use whichever language you prefer. To get started, you're going to need to install the latest version of Neovim on your system. As of the time of recording, that is 0.9.1. Go ahead and install it as per your operating system. I'm using Arch, by the way, so I'll install it using Pacman. With Neovim installed, the next thing you're going to want is to install a nerd font. This will provide some really nice icons inside of Neovim. Personally, I use the JetBrains Mono nerd font, as it's one of my favorites. Make sure to install it as per your operating system. With the font installed, you'll also need to make sure your terminal application is configured to use it. I'm using Alacrity, so I just need to add the entry to my alacrity.yaml. The final dependency you'll need to install is Git, which will allow us to download our base configuration. Make sure to also install this as per your operating system. With our requirements installed, we can now begin setting up our configuration. To assist with this, we're going to install a base configuration to give us a number of features out of the box. There are a few decent base configurations out there for Neovim, but for this video we're going to use NVChad, which provides a decent set of default packages and settings, but also the ability to easily customize. If you're coming from an existing installation of Neovim, you'll first want to back up your configuration folder using the following command. Afterwards, make sure to go ahead and delete your Neovim cache. To install NVChad is as simple as running the following command, which I've also linked in the description. Once it's finished, go ahead and open up Neovim using the nvim command. You'll be greeted with a tiny prompt at the bottom of the screen asking if you want to install an example configuration. Go ahead and type n as in no, so you can start from the same point as I do in the video. After submitting your entry, you should then see NVChad and the lazy package manager perform some initial downloads and setup. Then after a while, you'll be greeted with a lovely FAQ, which I recommend reading if you have some time. The last thing to do is go ahead and select a new theme. We can do this by opening up the theme switcher using space, T and H, and selecting a new color scheme. I'm going to choose Capuchin because, well, it's the best. With that done, our base configuration is set up and we're ready to add our first feature. The first feature we're going to add is code suggestions and auto-completion, with some additional light static analysis. We're going to achieve this by installing an LSP, which provides a number of editor features out of the box. In our case, we're going to install the TypeScript language server, which works for both JavaScript and TypeScript. To add this, we're first going to need to open up our Neovim configuration directory. To do so, first navigate to the directory in a terminal window, then open it up using Neovim. Once inside, you should be greeted with an empty void. To navigate around the directory, we're going to need to open our tree view. You can do this by pressing Ctrl and N. With the tree view opened, head down to the lua/custom directory and open up the chadrc.lua file. This file is used for storing our general NVChad configuration. Inside of this file, you can see that we're creating a Lua table called M and setting the UI's theme value to be Capuchin. This was done when we selected our theme earlier. Underneath the UI, go ahead and add in the following line. This line tells NVChad where our custom plugins file will live, which allows us to add new plugins or configure existing ones. We've defined this file name as custom.plugins, which in Lua means the custom/plugins file, which we need to create. To do so, head back over to the tree view and press the A key. This will generate a prompt at the bottom of the screen, which we can use to create our new file with. Go ahead and give this the name of plugins.lua. With the file created, press enter to open it up, and add the following lines of code to create a new empty Lua table called plugins and return it. Here is where we're going to initially set up our TypeScript server. However, the first thing we need to do is make sure it's installed on our system. You can install the TypeScript language server using your operating system's package manager, but I think it's better to install it using a plugin called Mason, which acts as an external dependency package manager for Neovim. The benefit to using Mason is it keeps our configuration as code, which is a very good thing. To use Mason, first add in the following entry into the plugins table. Next, add in a table for both the options and the ensure installed values. Inside of the ensure installed table, add a line for the TypeScript language server. With our plugins table set up, we now need to close and then reopen Neovim. Once we're back inside, we can then use the Mason install all command to download and install the TypeScript language server. This command basically installs anything that's in our ensure installed block, which is really nice. With the TypeScript server installed, the next package we're going to override is the neovim/lsp config package, which provides a number of LSP configurations out of the box. To do so, add in the following entry to our custom plugins table. Inside of this entry, go ahead and add in a new function for the config, which we'll use to specify some configuration. Inside of this function, first import the default NVChad configuration, and let's add a new line to import our own custom one, which again we're about to create. To create this file, let's go back into our tree view, press the A key, and add in a new directory called configs and a new file path called lspconfig.lua. Then go ahead and open this file up as well. Inside of this file, we're going to store all of our LSP configuration, which is only the TypeScript server at this stage. First, import the default NVChad configuration using the following line. We then want to pull out the onAttach and capabilities functions from the default configuration. Next, you'll want to import the Neovim LSP config package. To set up the TypeScript language server, add the following line which calls the setup function of the LSP configs TS server, which is the TypeScript language server. Inside of the configuration table, add in the onAttach and capabilities values that we pulled out of the default NVChad config. Next, you'll want to set the initoptions.preferences.disableSuggestions value to be true. When testing this config, I found that the LSP server would often provide suggestions that weren't able to be acted on, which just caused needless clutter. Therefore, this option disables that, making the whole experience cleaner. Now let's go ahead and test this. If I jump on over to a TypeScript file, I'm able to get code suggestions when I type in the module name. I'm able to cycle through these suggestions using Ctrl-N or Ctrl-P, which stands for next or previous. As well as TypeScript, the code completion also works for JavaScript. Here you can see I have order suggestions for my require statement, which shows me a list of Node.js packages I can import. And with that, our LSP is working as expected. The next feature we're going to add is in-code static analysis or linting to our projects. There are a number of different linters for Node.js out there. Whilst doing my research for the video, I really wanted to use a tool called Biome. However, I discovered there was a real lack of Neovim support. That being said, this project is still pretty appealing to me, for a few reasons. The first is that it's an opinionated linter, formatter, and analyzer all in one, and the second is that it's written in Rust. Therefore, I'm going to attempt to build a custom Neovim plugin to use this in the future, especially as it provides its own LSP server. If you're interested in me doing a video on this, then please let me know in the comments down below. So as I wasn't going to use Biome for this project, what was I going to use instead? Well, I decided to use ESLint, as it's pretty ubiquitous and used across a lot of JavaScript and TypeScript projects. And so the first thing to do was to get ESLint installed. Now, there were some caveats with this, as ESLint can be installed either in a project or on a system. Fortunately, Mason can cover this using the ESLint LSP package, which provides support for both. So, let's go ahead and add that to our installed options and run Mason install all. Next, we needed to decide how to actually load this into Neovim. Historically on this series, we would use Null-ls to do this. However, it has since been archived, so we needed another option. I wanted to take inspiration from what the rest of the Neovim community were using. However, like some British wartime propaganda, they had decided to keep calm and carry on. Therefore, I decided to follow the advice of the creator of NVChad and use some different solutions. This solution was mvim-lint, which provides bindings for a number of different linters. Whilst it doesn't support Biome out of the box, it does support ESLint, so we're going to use it. To do so, let's add an entry to our plugins table in our custom plugins.lua. Inside of this entry, we're also going to add a config function and import a custom configuration. This will be our lint.lua file that we're going to go ahead and create now. Then let's open up this new file. Inside, we add in the following lines to set up ESLint for both the JavaScript and TypeScript file types. If you want, you can check out the documentation for other supported linters and add them to different file types if you like. Next, because this linter is not LSP based, we need to add in a method so that it lints whenever we save our file. This for me actually is a bit of a drawback, and I much prefer the behavior of the Null-ls plugin, but more on that in a minute. Go ahead and add in the following lines to set up a new auto command for whenever we save. This command will run after we save and will call the try_lint command of the package. With that done, we can go ahead and test it out. To start with ESLint, you'll first need a .eslint.rc file inside of your project directory. This file allows you to configure your linter for whatever rules you want it to run. You can generate an ESLint file by using the npm init @eslint/config command, and filling out your configuration as prompted by the tool. Next, I have some JavaScript code here to show the linter working. In my case, my code should expect to have semicolons and to use double quotes instead of single ones. You'll notice that I have no errors at this stage. However, when I go to save my file, the errors will appear. This differs from an LSP approach, such as with Null-ls, which will show the errors as they happen. For me, I prefer the Null-ls behavior over this, so I'm going to show you how to actually set up Null-ls later on. However, remember that Null-ls has been archived, and Neovim lint will last much longer, so the choice is yours. Before I show you how to set up Null-ls for linting, let's look at our next feature. The next feature we're going to add is auto-formatting whenever we save. Just like with linting, I originally wanted to do this with biome. However, because of the same reasons, I decided to go with Prettier instead, which is another opinionated yet popular code formatter. We can install this with Mason by adding Prettier to the ensure installed block. Then we just need to run the mason install all command. If you don't see Prettier being installed when you run the command, restart Neovim and try again. With Prettier installed, the next thing we need to do is configure it to work with Neovim. Again, this would have historically been done with Null-ls, and therefore I needed another option. So for this, I went with formatter.nvim, which was recommended on a GitHub issue for NVChad. Setting this up is pretty similar to the nvim lint package, and we start by adding an entry to the plugins table. This entry also loads in a custom configuration, however it does so in the options block rather than the config block. Next is to go ahead and create this custom formatter configuration. To do so, create a new file in the configs directory called formatter.lua. Open this file up and create and return an empty Lua table. Inside of this table will contain another table for our file types, where we will specify the different formatters we want to use for each file type respectively. Inside we'll add the Prettier formatter for both JavaScript and TypeScript, whilst also adding a trailing whitespace remover for any file type. Next, we need to enable auto-formatting whenever we save. This is different to how we would do it with Null-ls because the package is not LSP based. So to set it up, just add in the following 3 lines. This will create a new auto command for whenever we write to our buffer, which we'll call the format write lock command. With that, we can now go ahead and test our auto formatting on save. Heading on over to some poorly formatted JavaScript, at least according to Prettier, when I save the file using :w, the format is automatically corrected. So this works as intended, but it still feels a little bit janky when compared to Null-ls. Additionally, when I tried to save an empty file later on, an error would appear periodically. Overall, it didn't feel like a perfect solution, but it did get the job done. So I do recommend giving this a go, but you may feel like me and want to still use Null-ls. Fortunately, I can give you a quick speedrun on how to do that. First things first, you'll want to delete both the formatter.nvim and nvim-lint entries from the plugins.lua table. Then you can add the following lines to add Null-ls as an entry. You'll notice we've specified a custom Null-ls config file, so go ahead and create it. Then inside of this file, add in the following lines to load up both Prettier and ESLint. Additionally, if you want auto-formatting on save, you'll need to add in the following onAttach function. If you're interested in how this works, I recommend watching any of my older videos in the series. With Null-ls setup, we can go ahead and test this out. As you can see, the linter runs dynamically, rather than after saving the file, which may or may not be to your preference. Additionally, the formatter works as an LSP, so you can use the space F and M commands in order to format this manually. With that being said, whilst Null-ls does have a better user experience, the project is archived, so it will eventually no longer work, unless we see new maintainers for the project. Now that I've shown you how to both add formatting and linting via Null-ls, let's move on to our penultimate feature. The last big feature we're going to add is debugging for our Node.js code from within Neovim. To do that, we're going to use a plugin called NVIM-DAP, which stands for the Debug Adapter Protocol, and allows for text editors to communicate with debuggers. In my research, there were a number of different debuggers for Node.js, with the most popular one being Node 2. which is unfortunately archived. However, this has been replaced with the official VS Code debugger, which also happens to work with Neovim. To set this up, we need to install this debugger using Mason. To do that, go ahead and add the following entry to the ensure installed block. Next, we can add an entry to our plugins table for the Nvim DApp plugin, and inside another config function which imports, yet again, another custom configuration file. This is the last one, I promise. Next, go ahead and create the dap.lua file in the custom configuration directory and open it up. Inside of this file, we need to define a DApp adapter for PWA node, which will connect to the JS debug adapter server. Afterwards, we can specify a configuration for both JavaScript and TypeScript, which will use the PWA node type and launch it against the current file we're working in. This is a little bit of boilerplate at this stage, but just bear with me. With that, we have a working debugger, but we want to specify some UI to go with it. For that, we're going to use the Nvim DApp UI package. To do so, we just need to add the entry into our custom plugins table, and make sure to add a dependency to Nvim DApp. This means whenever this plugin is loaded, Nvim DApp will be loaded as well. Next, create a config function with the following lines of code in it. This code adds 3 different event listeners to Nvim DApp, which hooks up to these callbacks when events happen. This means the UI will automatically open when the debugger is ran, and automatically close when the debugger is exited. With that, the debugger is set up. However, I like to add some custom key mappings in order to make debugging just a little bit easier. To do so, first create a mappings.lua file in the custom directory. Inside, create a new Lua table called m and return it. Next, inside of this table, specify an entry for DApp. This is where we're going to store all of our DApp-based mappings. Go ahead and set the plugin value to true. This means the mappings will only be applied when we explicitly load them. Next, we'll go ahead and set a table for the N key, which means normal mode, and add in our first mapping for the leader key, or space key, D and B. This mapping will toggle a breakpoint at the current line our cursor is on. We'll also want to add a new mapping to run our debugger. Let's go ahead and set this to leader, or space, D and R. This will call the DApp continue command, which will both start the debugger or resume it if it's already running but paused. With our mappings files set up, we just need to go ahead and load them. First, head back on over to the plugins.lua file. Inside, add the following line to the Nvim DApp configuration function. This will load the DApp mappings whenever the Nvim DApp plugin is loaded. The final thing we need to do is jump on over to the chatrc.lua file and import our mappings, assigning them to the mappings key of the M table. With that, we can go ahead and test our debugger. Heading on over to a Fibonacci function I made earlier, we can set a breakpoint on our current line by using the space, D and B mappings that we configured earlier. You can see that a breakpoint is active by the letter B next to the line number. With our breakpoint set, we can go ahead and run our debugger by using the space, D and R key mapping. Once the debugger is run, a number of windows will open up. This is the Nvim DApp UI, and gives us a bunch of information about our debugging session, as well as a number of buttons we can use to control the debugger. And with that, we have working debug capabilities from within Neovim. Now, typically this is where I would finish up these videos in this series, but I wanted to have one little extra treat to share with you. So let's jump on over to the final feature we're going to add. For this final feature, we're going to add the ability to organize imports in TypeScript from within Neovim. Whilst this isn't a killer feature to make the perfect Neovim configuration, the idea of this is to get us working a little bit more with LSP, in preparation for if we decide to build our own plugin for use with Biome. To add this new feature, head on over to the custom LSP config file we created earlier. Inside of this file, just above the TS server configuration, let's create a new function called organize imports. Inside of this function, create a Lua table called params. We'll send the contents of this table to our LSP server. The first parameter we want to send is the LSP command, which is the _typescript.organizeImports command. And the second is our arguments field, which will contain the current buffer's file path. With our parameters defined, we can go ahead and call the execute command of the vim.lsp.buff API, whilst also passing in our parameters. This allows us to send the command to our LSP server. Next, we want to specify a custom Vim command so that we can call this on demand. To do that, add in a commands block to the setup function of the TS server, and add in a new command of organize imports. Inside of this table, specify the organize imports function and give it a nice description. Now, if we jump on over to some TypeScript code, we can invoke this command using the colon key followed by the command name, which is organize imports. The LSP server will then organize our imports for us, as well as removing any that we're not using. Pretty neat, but the real power here is that you just managed to create your own LSP binding all by yourself. And that wraps up the almost perfect Neovim configuration for Node.js. I want to give a big shout out to my channel members for choosing this as the next video to do in the series. If you'd like to be able to vote on the next language I do in the series, then please consider joining. A link is in the description down below. As always, you can find the source code of this project in the description. Otherwise, thank you for watching, and I'll see you on the next one.